Welcome to IM1's 2.6 day 1. Concept is solving absolute value inequalities, and we're only going to focus on the less than inequality. So that's the inequality that looks like this. Okay, less than or equal to. Okay, so the first thing I want to do is make sure that we can understand how to read this sentence frame. So number one here, this says the absolute value of x is less than 2. So what this really means is we want all numbers that are less than 2 units away from 0. That's what we mean by that. So if I was on the number line and 0 was here, then I could be over here at 2, or I could be over here at -2, and I could have any number that I want inside this region, because any number in this region would be considered less than 2 units away from the number 0. So this is what we're looking for here. We're noticing that when we have a less than statement, we're looking for like an and compound inequality. If we compare that to number two says all real numbers that are greater than or equal to 2 units away from 0. So that would be this graph. Okay, so again, if I drew 0 here, 2 there, and -2 here, I want every number that is more than 2 units away from 0. Okay, so if this is my 0 here, right? So this is 2 units that way and 2 units that way. I want all numbers that are more than that. So notice that when you have a greater than sign, we're going to have an or statement. That's going to be very, very important. Okay, number 3, this says all numbers less than 5 units away from -3. So if I was on the number line, okay, I would put -3 here, okay? Or sorry, excuse me, I'd put 0 here. I'd go -3 or -3, sorry. Anyways, put on the number line, let me back that up again. On the number line, all numbers that are less than 5 units away from -3. So actually what I would do, if this was -3, okay, I would go 5 units to the right, and that would put me at a +2, and I would go 5 units to the left, and that put me at -8. So I would have these numbers here. Any of those numbers right there are less than 5 units away from -3. That's what that means. This one means, number 4 means all numbers that are greater than or equal to 5 units away from +3. So if I'm on my number line and there's 0 and here's 3, and I go 5 units to the right, that would be 8. If I go 5 units to the left, that would be -2. And I want all numbers more than this. Okay, so that's this direction and this direction. Okay, and the last one, this says all numbers less than or equal to 3 units away from -2. So again, on my number line, let's put 0 here, let's put -2 here. Okay, so I want to go 3 numbers to the right, that would put me at 1. And then 3 numbers to the left, that put me at -5. Okay, so I want every number that's less than or equal to 3 units away from -2. So this is what we're going to be working with throughout this lesson, and hopefully it makes some sense to you what we're doing so far, okay? Okay, box number 2, we're going to solve a less than absolute value inequality. So it says solve and graph the following. The absolute value of x plus 7 is less than or equal to 2. So we want all numbers that's less than or equal to 2 units away from -7. So here's the steps over here. The first thing that we're going to do is we're going to isolate the absolute value. In this case, the absolute value is already isolated. That's this part. So we've done step 1. Step 2 says set up the correct inequality, and here's how you do it. So since we have a less than symbol, we're going to take -2 less than or equal to x plus 7 less than or equal to 2. So you're noticing that if I want to be less than or equal to 2 units from whatever this happens to be, then I am going to sandwich whatever is my absolute value is in between the opposite number and the positive number. So this is called like the sandwich method, what I call it, with absolute value inequalities. So that's the correct setup. We're going to isolate the variable. So the variable is x, so I'm going to subtract 7 from both sides. Okay. So this is going to be -9 is less than or equal to x, which is less than or equal to -5. So on my number line, okay, I'm going to put 0 here, for good measure. I'm going to put -9 there. I'm going to put -5 here. And the number that's in the middle of these guys would be -7. Okay? And so I want all numbers that are less than 2 units away from -7. So I could be here, or I could be here. So this right here represents 2 units, and this right here represents 2 units. So I want anything in here, and that's what I was trying to get the point across in that first one, showing you that this is what this means, right? This is 2 units away from the number -7. So I could either be at -5 or I could be at -9, and this is how we do it. Okay, box number 3. Let's solve this one. Again, let's isolate those absolute values first. So I'm going to say this is absolute value of 5x plus 10 is now less than or equal to, if I add 3 to both sides, right? 18, 19, 20, 21, okay? And then I'm going to set up the correct inequality. So -21 is less than or equal to 5x plus 10 less than or equal to +21. We're going to isolate the variable. So I'm going to subtract 10 everywhere on the left, the middle, and the right. That's going to give me -31 is less than or equal to 5x, which is less than or equal to 21 minus 10 is 11. All right, I'm going to divide everything by 5 because I'm still needing to isolate that variable. And I have -31 over 5 is less than or equal to x, which is less than or equal to 11/5. So all I have to do to graph that, very, very easy. Here's -31 over 5. There's 0. There's 11/5. They are closed dots above, and I want everything in between. Okay? That's all you got to do. So -31/5 less than or equal to x, less than 11/5. Okay, you guys try this one on your own. Let me know how you do, and I'll show you the answer in just a second, okay? So again, let's isolate that variable. So 2 times 3x plus 8 is less than or equal to, add 13 to both sides, add 13 to both sides, so 13 minus 5 is 8, okay? Then divide by 2. Cancel that out. So the absolute value of 3x plus 8 is less than or equal to 4. Do your setup, -4, less than or equal to 3x plus 8, less than or equal to 4. Your little sandwich method there. Isolate that variable, so subtract 8 everywhere. Okay, so that's going to give you -12, less than or equal to 3x, less than or equal to -4. Divide everything by 3, and we're going to have our answer, -4 less than or equal to x, less than or equal to -4/3. So when I graph this, here's -4, there's -4/3. I want colored in dots because it says less than or equal to, and we want everything in between. Okay, so in summary here, when you're given the absolute value of ax plus b is less than c, it always becomes the following. -c is a less than whatever is left over inside your absolute values, which is less than +c, and on the graph, it will always be some kind of a and statement, which means it'll be some kind of a graph that looks like that. It will not be an or statement. Okay, tomorrow, next time I see you, we're going to get into the or statements and the greater than statements, so stay tuned.